All right. Well, there we go.
Dan presented. We did record it. We're all witnesses. Dan did his presentation. It was great.
All right.
Click start recording.
Well, very good. So I'll go ahead and jump off, and I will review your guys' presentations this evening when I get back.
Cool.
And I'll see you guys on Tuesday.
See you, Dan.
Bye, guys.
Bye.
Okay. So the portion that I was assigned was the JUnit tests. So the purpose for JUnit tests is to basically prove your method that your algorithm works as you expect it to, and that it tests the outcomes, and that it tests it in multiple scenarios. So you have multiple pass scenarios of the minimum and the maximum of the allotted values that you have, as well as values outside of what you expect and the kind of error codes you expect to return. The other final purpose for this is it helps you create better quality code. It allows you to sit down, create test cases that you can think of, and build out these test suites that test it for you and allow you to see if it's doing it as you expect it to. The components that are part of JUnit tests are the fixtures, the test suites, the test runners, and JUnit classes. The fixtures are the static variables that you give it for each test case. So here in a second, well, actually, I'll just show it now. This is a test case that we had for a game from the 260 class. These were the fixtures for each test case scenario. It had the input as well as the expected output for each of these test cases. After that, so the test suites would be basically your entire set of tests here. So I've got multiple test cases here for everything that could have been out of range, which there were up to 10 options. So this would be the test suite for the method reduce health dot. So that was basically us testing that method out. And so test runners, that is each of these individual calls that actually test the results and store them. In this case, we just stored it in the results. And when we called the actual part of where JUnit comes into play here are all of these assert type of methods. So in this instance, assert equals had two variables and a variance of how much you wanted it to where it would be equal, which in this case we wanted it to be exactly equal. So I put 0.0, and that's where you put in your expected results, and you put in the results from the test, and it tells you if it's yay or nay. So I'll go ahead and run this real quick so you guys can see. So for each, there are two different test suites in here, by the way. There's the normal, reduce health normal, and reduce health dot. And each of these test cases came out 100%. So if it comes out with an error, it'll stop in the code right where it had the issue, and it creates an exception. So, but you can use these test cases from, I mean, if you start having issues after you've gotten halfway through the program and you're not getting what you expect, you can run your test case again just to make sure something wasn't changed and they come out the same. So we've got different test case here for different storage controls that allowed us to pull and put items in the storage that we had. So that's JUnit testing. Anybody have any questions?
No.
I'm good.
I'm good.
Cool. Who wants to go next?
I'll go. No problem.
Okay.
All right, MVC. It's the Model View Controller. method is actually pretty much considered the way to do things now. I'm going to share my screen to show you guys more. So there's three parts of it, and everything has to do with how all three parts interact with data or a database. The model is pretty much how it handles the logic, how it retrieves and stores information, like the core, basically. The view displays what's going on, and then the controller is what the user interacts with to change the model, which updates the view as well. I had a hard time looking at just when you look it up, you're going to see this trio picture, but it's very hard for me to understand why or how a user interacts with it. So I found this lovely thing here that shows you how the user interacts with it. The user sees the view. He uses the controller to manipulate the data in the model. The model then updates the view, and then the view is then displayed to the user. Now this is important because all three parts can be swapped out interchangeably. Like I can replace the view with a different type of view, and it should still, if done correctly, pull the same information from the model, and the controller still controls the model the same way. I can replace the controller with a whole different new controller. Like instead of using keyboards, use a mouse or use a touch screen. It still is going to manipulate the model the same way and update the view in the same way. So that's the whole idea, is these parts are interchangeable to what you need. If you need to replace how the model processes the data, you can swap that out. It's just the view should still work, the controller should still work if you coordinate the classes properly, and the model will handle the data differently. I have an example here in NetBeans. There we go. All right. So you can just see in my main, I load all three controllers that I have. I load the model, the view, and the controller. And then I start it all, and I get it going. Now the controller, like I said, it handles the data. So it's taking its selection events and mouse events, and then it's manipulating the data on here. In this case, it's a basic paint program, similar to MS Paint. MS Paint is a MVC model. So this takes the input and it stores the data, updates the picture. That's what the controller does. The model is how it processes it all. It goes, okay, these points, I got to add the counts, I got to mark it a certain way. That's then saved and retrieved. And then the view, basically it displays what's going on with the JLists. Well, not the JList, the paint panel. It displays what's going on in the paint panel and uses JLists and JPanels to display all the menu to objects. And these are all the lists for the objects here. So when you run it, it becomes just like a, oh, you can't see that, awesome. There we go. So when you run it, it becomes a basic paint program. Like you can change the color of the side. That's part of the controller, and I'm seeing the change update here. And then I can use my mouse to draw stuff. Now I'm using the mouse as a controller. The controller updates the stuff in the model, and then the model updates the view so I can see where I've drawn. And basically I can swap out the controller part so it looks totally different, and it should still work. So that's the whole idea with MVC.
Cool.
Awesome.
Very good.
Thank you, Brandon.
Yep.
Who wants to go next?
I'll go.
Any questions?
I don't have any questions, but I'll go. That was very good. So I don't want. That's a tough act to follow.
Nah.
This is the third time I've done this, so I
That's
know what
true.
I'm doing.
That's true. I'm gonna share my screen. I had the JSON serialization, and I had seen JSON files before, but I've never really understood them until today, and that's probably why we're doing this exercise. JSON stands for JavaScript Object Notation. It's a file format that's used for flattening data structures into strings, and those strings can be easily transferred either into memory or by a server to a client, mainly over web. JSON is very similar to XML, but XML is a little more fatty and a little bit bigger, and so it's easier to send JSON across wires and into memory than XML just because of the size. The subject is JSON serialization, and what that means is it's a process that converts objects, Java objects. This can also be used in C++ and a bunch of other languages, but specifically for Java, it takes Java objects, whether that object is a string, a picture, a file, it converts that into a string that can be easily stored into memory. Or in the instance of a web server and a web client, it can transfer that across the network. And remember, when you're doing networks, smaller is always better, and it's always faster. So JSON is getting pretty big. It's replacing things like the Flash media player, Flash type things, because it's so much easier to send that across the network. So the process of putting the object into this JSON format is called serialization. The deserialization, which I know it's not part of the subject, but it is part of JSON. Deserialization is done at the client level, where it puts those back together through a virtual machine, JVM or something else, and puts them back together and gives you the object, whether it's a graphic, a movie, a file, or just a character on the screen. So that's what JSON is. I had to ask the question, well, what's wrong with XML? Because if you look at an XML file versus a JSON file, they look the same. And I've got a file right here that I'll show you. This is at the top. Don't pay attention to the bottom part. Can you guys see that okay, or is it too small?
It's good for me.
Okay. I'll just make it a little bigger, because this is a JSON file, and it gets put into this format through the serialize command, or in Java, and I'll show you that in a second. So you can convert these objects into streams, and this is what the stream pulled apart. This is what it looks like. This is what is sent to the client from the server, or is sent into memory. And the exact same thing written in XML looks just like this. And so the question I have is, that doesn't look very much bigger to me. So I still have some research to do. So I don't know the answer to that question, but I will find out. So that's a JSON file. That's an XML file. And there are two formats for the exact same type of data. So I played around a little bit in Eclipse with some JSON stuff. And if you look at the main, hang on, let me see. How do I get this Project Explorer open? There's errors in it because I haven't completely debugged it, but you've got your main class, and you have a subclass. If you've seen the commands in Java before that say file output stream, that is a serialization module, and it will put this up top, these variables, into that format, and it'll dump out a file that looks just like this. So the exact same type of, just the same format that we saw earlier. And so that is serialization in a nutshell. The code is not that complex. In fact, many built-in modules you can just call them straight. Not a lot has to be imported. In fact, the reason why I have errors is because I can't get one of these to import, or I'll import it and it says it can't find it. So it's just an Eclipse thing, and I'm still trying to work through it. But these errors down here, it's because this isn't working for whatever reason, even though the import is right here. And there's really not a built-in deserializer or a serializer in Eclipse or NetBeans. You've got to go out and find one. And this Cedar software is one of the best ones. Apparently it's fastest. I don't know why. I haven't figured it out yet. But Google has a whole bunch. But Google's format is called GSON. And it's just a little bit different. But you can import those in as well. So does anybody have any questions? Did I explain it okay?
No, I'm good.
Okay.
Yeah, I don't know what you're complaining about going after the other guy, because yours is good too.
Well, I spent a lot of time trying to figure it out.
You mind if you show the main.java again?
Yeah.
Just wanted
This is main Java right here. And this is where it runs.
It looks like JSON.java.
No, I'm sorry. The main Java works with employee.java. And actually, this will work. This will run. Save and launch. Yes, proceed. Yeah, this just says it was serialized, and then it writes out a file, which is right here. But
I'm curious where it gets the location data from. I wasn't seeing.
it is right here. Like where to put the file?
No, in the address. There it is. Okay, I guess if you look in the actual JSON,
Yeah.
it has location, and then with some the data, the actual data that was written.
This one here.
There you go. Location, city, and state. I was curious where it was getting that from. Because in the main.java, the address is Colorado Springs, Colorado. It must be doing some kind of conversion. I was just curious. Okay.
No. I messed with that because I was trying to reverse it. So I just saved this.
Okay.
The actual file that it's pushing out is right here, but I didn't open that one.
Well, I can go next if you guys don't mind.
Okay.
I'm going to try and screen share. I've never done this before. Let's do...
Should be the big button.
Guys.
Yep, I can see it okay.
Okay, great. All right, so I got UML state diagrams. I'm not the best person on UML diagrams, but I'll give it my best. So what is a state diagram? It's a state diagram shows the behavior of classes, and Jason talked a little bit about classes, and in response to external stimuli. Like more specifically, a state diagram describes the behavior of a single object in response to a series of events in a system. I noticed a lot in my 262 class last semester that people would get a state diagram confused with a flow chart. It's just a little bit more complex than a flow chart because like a flow chart will illustrate the processes that are executed in the system that change the state of the object, but a state diagram shows the actual changes in the state and not just the process or commands. An example here, I don't think you guys can see that very well, can you?
No.
Okay, let's...
There you go. That's better.
Whoops. Okay, so this is a state diagram of making coffee. Not something that we do, but it's just a good example.
Yeah, as an intern, you're going to do it. I guarantee it.
Luckily, my internship is at an office where it's all LDS people, so I hope we won't have to do that. But as you can see, with every case, there's two halves to it. The first half on the top is always the external stimuli, what's happening. Then as you see in the second half, it says do / and that's what's going to happen in response to the external stimuli. So if you look at the top, it says turn machine on, do / heat water, coffee pod placed in pod holder and closed, and then it prompts for the brew size. The brew size is selected, adjust water output and brew complete, and then the machine idles. And as you can see, there's a line that goes all the way up to one, because at that point you can choose whether or not to make a second pot of coffee. So that's like the most simplistic example that I could find of a state diagram and explain to you guys without taking up a whole lot of time. But I think obviously this would be very beneficial once we actually start writing code, so we can.
I'm sorry.
Okay. But I appreciate the applause. But
As I was saying,
I was waiting for that. I'm so sorry.
But yeah, I think using something like this when we start actually writing code would be very beneficial for all of us, so we can see and understand and be on the same page as to what's going on or what we want a program to do. So do you guys have any questions about that?
No, I'm good.
Okay, awesome.
No, that makes sense.
Perfect. Thanks, guys.
No problem. Alright. I guess it's my turn. So I had use case diagrams. And so basically use case diagrams is a graphic depiction of interactions held by a system. These diagrams are actually commonly used in analysis to discover and organize the requirements for those systems or for programs. So basically, in simpler terms, this kind of helps us define what the system does, as well as how the relationships between all the cases that the system is going to have relate to each other. And generally speaking, there's always a couple of different elements that go into a use case diagram, and most of those are actors and use cases. Actors are generally speaking the people who are directly influencing the system, and use cases are generally described with verbs or specific functions that the use case actually performs. So this is actually a use case diagram I made in Visual Paradigm. I didn't take the time to necessarily understand the restrictions that Visual Paradigm does to actually get the actual extensions, so these arrows are actually relational, but I put extends on the ones that are extend and made sure that all the arrows were pointing the right way. But regardless, so on the left here you actually see our actor, and this can be an individual that's going to be interfacing with our program. In this particular use case diagram, I'm actually representing a drawing program, and basically it just kind of has a couple of different ways that it works. So in regards to that, so it's not actually determined by whether or not it doesn't actually have a controller for your mouse. So you actually have to instigate the pen state, which is actually extended by pen up or pen down. So if you're pen down, then you actually have to indicate the pixel distance. Then you have to actually indicate the amount or the direction that's going to be facing. Actually, this is a internally function. The user doesn't have control over this, which is why there's no connection between the actor and the direction. And then you have a turn left and turn right button, which actually directly influence this direction. So this is just kind of how the relationships work, and how they're all responsive to each other. There's actually a couple of different variables that are sometimes found in these use case diagrams. One would be like sub-actors, which are basically just actors that are directly influenced by the diagram that don't actually directly interface with the program. And then also, along with extend relationships, there's also include relationships, which is an extend is basically like an optional is a relationship. So like turn right is a direction. And likewise, a include is a has a. So like a person has a watch, and it's directly it's mandatory by the previous use case to be included. Does that make sense? Does anyone have any questions about that?
No, that makes sense to me.
Is that Turtle 1?
Yeah, it is actually.
It looks like Turtle 1. Okay.
Yep.
So yeah, this is actually the Turtle 1 program use case.
262, if anybody's taking it, yeah.
Yeah,
Yeah,
that's
I actually
right.
I had to make this, so I figured I'd conquer it too.
It took us forever to make. We had to do it as a team, and it took us forever.
Yeah, it was a team. Well, actually, I did this by myself, but there's 2 or 3 of us that I was able to pull inspiration from. So,
Cool. Well, you did a good job. It's tell you it could. You can tell you understand it.
but anyways, so there's no questions. What else is on the agenda for this meeting?
That was it.
That was
We
it.
just have to present our stuff and we're done.
And I think we need to, if we haven't already, I haven't looked at the other ones that they posted today.
I haven't either.
I didn't see any on there.
I saw Ashley's. She posted it a
I
couple
saw that
hours
she
ago.
posted. I haven't looked at it yet, though.
Although she posted hers, where was it?
Did she post it to the main forum then? Because I don't see it on ours.
Uh-oh.
It might be. I saw it earlier. Let me look at.
It's on my phone, so I think she may have posted it in Hangouts, possibly.
Interesting. Yeah, I see Dan's. He just posted that before he left, but that's it.
Where did I see it then? Unless she took it down.
So I think I'll post the example I use and in some of the things that I explained, just so it makes more sense to Brother Tuckett when he sees it.
Yeah, that makes sense.
Where are you gonna post it? On the community or?
In the drive.
Oh, that's right.
Cool.
All right. Well, thanks, guys.
Yeah. I'll see you guys later.
Yeah. See ya. Have a good.
Bye.
weekend.
Bye.